Continuing with section 3.2, we now look at some examples. So remember, for steps for graphing polynomial functions, what we do first, we have to factor the polynomial. Sometimes you will be given the polynomial already in the factored form. Anyhow, so by factoring, we can easily see the zeros, or what we call the x-intercepts. So that's what we need to find. Then we have to make a sign chart using those x-intercepts as critical numbers. Determine the add behavior of the polynomial, and then make a table of values for some extra points if needed, and then also find the y-intercept. But then we plot those points and we then try to graph our function. We will also look at the multiplicity of the zeros. Then we use the sign chart, the multiplicity, and the end behavior to sketch the graph. And in the end, we will label the intercepts and the local extrema. The local extrema means local minima and local maxima. Extrema is the plural of extreme, and minima is the plural of minimum. Maxima is the plural of maximum. So if we are talking about minimum and maximum, together, or like we mean both minimum values and the maximum, then we call them together, we call them extremum. Like a single minimum value or a single maximum value, so we are calling them extremum values. But when we talk, there are more than one maximum and more than one minimum, then we can call them a minima. For the more than one minimum, we call them minima. More than one maximum value, we call them maxima. And the plural, collectively, we call them extrema. Okay, so we have to sketch the graph of this function. So this is already in factored form, so one step is done for us, because at this moment you only know how to factor a quadratic, or sometimes like a fourth degree, but how to factor a cubic or a fifth degree or a sixth degree, or higher degree polynomial, that's something we have to learn. Okay, so from here it is quite clear what are zeros. So the zeros are 0 from the first piece, from the x, 1 from here, and then we have -1 from the last one. Okay, what is the multiplicity? The multiplicity of the x is 1, because that's the power on the 0. So multiplicity on the factor, so this is 1. The multiplicity of 1 is 3, and the multiplicity of -1 is 2. So what this is telling you is that at these 2 points, the graph will cross the x-axis. Okay, and at this point, at this 0, it will bounce back. That's what the these multiplicities tell you. Okay, so now next thing we have to do is make a sign chart of this. Okay, let's make it over here. Put them in order. So -1, 0, 1. Okay, so I'm going to pick like -2 here, maybe -0.5 here, 0.5 in this, and then 2 here. Now when we do the calculation, so it will be its decimal number in the middle, it will be hard, but anyhow, when we do the calculation, the -2 is easy. So I can just plug in -2 times -3 cubed times -2 plus 1, which is -1 whole square. So you see, this is giving me a positive value, this is giving me a negative value, and this is giving me has a negative sign outside. So we will end up getting a positive value, and the value is coming out to be actually 18. Is that? No, sorry, 54. Is it what we get? Yes. So we have 54 here, which is a big value. And when we do 2, we end up getting 18. But with negative 0.5 and 0.5. We can use a calculator at home. So over here I am getting 0.42, and at 0.5 I am getting negative 0.14. So you can see that when now AND behavior. Okay, AND behavior. So because how do we determine the degree or the lead term? That's what we will need to know. So lead term, in this case, please do not expand these. It will take up a lot of your time expanding and multiplying and trying to find what is the lead term. So we can easily find the lead term from x. The lead term is x. From x minus 1 whole cube, the lead term will be x cubed. Okay, and from x plus 1 whole squared, the lead term will be x squared. Okay? So the variable raised to the highest power, or the first term of your linear polynomial whole raised to the highest power. So if you have a term, if you have a polynomial like ax plus b times cx plus d times mx plus n, that it can have three factors, it can have more factors. Let's put some power. We have a second power over here, third power here, and let's say you have a third here. So the lead term will be, so from here you will get ax whole raised to the power 2. From the second we get cx whole raised to the power 3, and from the last we get mx whole raised to the power 3. So if you notice here, you get a square x square times c cube x cube times m cube x cube. So if you notice, the lead coefficient will be a square c cube m cube. So whatever the numbers are, that's what this will give you the coefficient, and then x to the 2 plus 3 plus 3, 8. So the lead, this will be the lead term, and the degree of the polynomial is 8, and this will give you the lead term. So from here we can see, because we have 1 1 1 in front of x's, so our lead term, the coefficient is 1, and our lead term will be x raised to 1 plus 3 plus 2, so 6. So we have a polynomial of degree 6, and we have the lead coefficient is positive. So our AND behavior looks like this. What is the next thing we have to do? We found the AND behavior. Now let's find the, let's put these points in a table, and then we will also need to find the y-intercept. So table of values. Because I will just rewrite these values over here, the one that I have for the sign chart. Okay. So now when we start to graph the function, if you notice, give a before you draw axis, try to look at what the numbers we are dealing with. If you notice, the x minimum value x we have used is -2 here, and then the maximum value is 2. Now y, you can see the minimum value is -0.14, and the maximum is like I mean, the one we have is 54, but it can be go because the end behavior is showing that it goes up and up and up, so it's infinity. So it means very little graph is showing below the y-axis, below the x-axis. So when you graph the function, your y-axis, the x-axis should not be too high up. So we have a little bit of the vertical axis below the x-axis, and then most of it is above. Also, now when you take, if you do something like this, 1, 2, 3, 4, 5, then the graph will look, because it has to pass through 1, it has to pass through 0, negative 1 and 0 and 1. So you see what happens is that your graph is going to look like very tiny, something like this, and like this, and then most of the things are happening over here. That is the interesting part. This is not interesting. This, we know that it goes on and on and on forever. So we need to try to graph the functions and put our tick marks such that it is visible, easily visible what is happening in the graph. So I would recommend that you make these big. At least in this case, at least the x, the steps on the x, you take them big, and the y you can take smaller, but we can never going to plot, be able to plot this. This is too big. Even this is too big. So we need to find some odd point, like what is the value at 1.5 or 1.2, 1.3, and then similarly on the left hand side. So let's see, at 0.5 we are getting negative 1.15. Okay, so if this is our 1, so negative 0.15 will be somewhere here, and at negative 0.5 the value is 0.42, somewhere here. Okay, so let's now try to plot the graph. So the end behavior shows that we have to come from here and we have to go up there. Okay? So I start from the left. I have to come here at negative 1. Now at negative 1, it will bounce back because of the multiplicity of negative 1 plus 2, so it will bounce back. And also you notice here in the sign chart that both to the left of negative 1 and to the right of negative 1, the value is positive, so it stays above. Now we come here, we have to get to this value. I don't know if this is a local max value, but somewhere here there should be a local max, because now we have to come to this point, to 0. So if you remember, the intermediate value theorem tells us that this will come here. Now x has a multiplicity of 1, so it will cross. Now notice here, when it crosses, it just crosses it like this, straight. Okay, and now it has to pass through this point again. Is this the maximum? We don't know, but anyway, now it has to pass through here. And what happens here now? Will it cross or will it bounce back? Well, according to our information, it should cross because it has a odd multiplicity. So when it crosses, it will not cross it like this. Okay, that's the difference between crossing when multiplicity is 1 and when multiplicity is any other odd number. So over here it crosses like this, and it goes up. Now if you put arrows here, it's okay. If you don't, that's still okay. But this is how over here it will show this behavior, the one if you recall from x cube. So this type of behavior, and then this is the graph. So we can say here is local, somewhere here will be local min, somewhere here will be local max. This is the point negative 1 0. This is the point 0 0 1 0. So I labeled all the intercepts and the local extreme. Oh, one thing we didn't find, actually we can see from here also, the y-intercept. So if you find the y-intercept also in the for the information, how do you do that? You just set x is equal to 0. So if you do that, you get p or y value is equal to 0. So 0 0 is our y-intercept as well. So this is how we draw the graph. Okay? And again, I would recommend not even do this, but even if you have space, draw it on a big page or big space like this page. It will be nicer. So I wanted to show you what I explained up there, that if you have a don't show if you draw a graph like this, it is a bad graph. Okay, because it's not, things are not visible what is happening near the zeros. This is okay, which is what, but this is the best, and this is how our graph looked like.